So, topic 1, sequences in the series. What are sequences? Well, okay, let's start off with that. A sequence is a list of numbers that is written in a defined order, ascending or descending, following a specific rule. So let's say something, for instance, like 1, 2, 3, 4 is a sequence, right? It's a sequence where the rule is you add 1, so plus 1, to the previous number to get the next number in the sequence. Straightforward. Now, a finite sequence, so a sequence can be finite or infinite. So a finite sequence has a fixed number of terms. So here we would have 4 terms. That's a fixed sequence. And an infinite sequence has an infinite number of terms, where we would say that this goes on to 5, 6, ... up until infinity, let's say. This would be an infinite sequence. Another infinite sequence could be 1, 3, 5, 7, 9, right? Here the rule would be you add plus 2 to each one of these, and then you get the next number in the sequence. And then this could continue on infinitely many terms in the sequence, and then we could call this another example of an infinite sequence. Now, if we truncated this sequence here at 9, we would have 3, 4, 5 terms in this sequence, and we could say that this is a finite sequence. Now, a formula or expression that mathematically describes the pattern of the sequence can be found for the general term un. So instead of trying to deal with, long strings of numbers in a sequence like 1, 2, 3, 4, 5, blah, 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 whatever it happens to be, what we're actually going to be working with is a general rule or general expression for the sequence in question. So something, let's say we take the original problem, 1, 2, 3, 4, 5, 6, and then let's say that the sequence actually ended here. Okay, so then we would have 3, 4, 5, 6 terms. What would be the rule? Well, it would be something like u1 plus n minus 1 times d. We're going to get into this in a few moments, where in this case d would be equal to 1, and then u1 would also be equal to 1. I'm going to explain this in a moment. But if we wrote down a sequence with a rule such as this, we wouldn't need to write every single term in the sequence. We could just say that this here is equivalent to this for values of n from 1, 2, 3, 4, 5, 6, 1 to 6. So from 1 to 6. Okay. Now, there are many different types of sequences, right? There are many different types. The only ones that you need to concern yourself with for the IB program is arithmetic sequences and geometric sequences. So this here in orange, here actually in purple, let's say, this is an arithmetic sequence. So a sequence is called arithmetic when the same value is added to each term to get the next term. So we've already given 2 examples of this. So let's say you start at u1. u1 just represents the first term in the sequence. So let's say un represents the general term, right? It could be the term of the sequence un, where n is equal to some integer value from 1 to whatever the range of this sequence or whatever the domain of this sequence might be. And so we can write infinitely many different types of arithmetic sequences as long as we know what the initial term is and what the common difference d is. So in this case, let's say un equals to u1 plus n minus 1 times d. That's the general expression or the general form of any arithmetic sequence. And then once we uniquely describe what d and u1 is, as long as we also tell you what are the possible values of n so that you can know how many terms in this sequence there really are, you can figure out every single term of this specific arithmetic sequence. So let's take a look. Let's say un equals to u1, where u1 will be equal to 1. That will be the first term of our sequence, plus n minus 1 times 1, where d is equal to 1 in this case. So what's really happening here? So whenever we deal with math, I don't want you to memorize formulas. I don't want you to be like, oh, okay, arithmetic sequences are given by this formula here, un equals to u1 plus n minus 1 times d. I want you to think about this formula, this expression, this equation. I want you to understand what's going on. So for instance, all you really need to understand about this expression here is that un describes, so this un describes some term in this sequence given by the integer n, right? So u1 would represent the first term in the sequence, u2 would represent the second term in the sequence, u3 would represent the third term of the sequence, and etc, etc, etc. That's all that really un means. You just tell me which term of the sequence this is, and based on the relationship between the terms, I can tell you what term you're looking for, what the value of the term in question is. Okay, so here we said we have 1, 2, 3, 4, 5, 6. And we said, well, therefore, u1 is equal to 1. So this u1 will always represent the first term in the sequence. Here it is, u1. And then this, what is this n minus 1 times d business? Like, what does this mean here? Well, all this really means is that, look, you have a common difference d. And what is the common difference in the context of an arithmetic sequence? It's the number you're going to add to a term to get the next term in the sequence. So for instance, if we look back at 1, 2, 3, 4, 5, 6, we started at u1 equals to 1. And then if u2 equals to 2, which is this buddy here, then the common difference between them is d equals to 1. And if you notice, this is an arithmetic sequence because the d, the constant term d, is going to be constant for every single sequence, or every single term in the sequence. So if you look at u3, so u2 is equal to 2, and then u3 is equal to 3, you can also see that the common difference between u2 and u3 is actually 1. And so as long as I know what the initial term of my arithmetic sequence is, and I know what the common difference is, I can figure out every other term in this sequence just by using this relationship here. Now, let's just talk briefly about this n minus 1 here. I know a lot of people get confused when they see n minus 1. What does this mean? Well, look, if you have some arithmetic sequence, some arithmetic sequence, un equals to u1 plus n minus 1 times d. Basically, what this says is that you start at u1, this is the first term, and then you're going to add a common difference of d n minus 1 times. Now, why is it n minus 1 times instead of n times? Well, because let's plug in n equals to 1. So let's say if n equals to 1, presumably un, right, would then have to be equal to u1. Well, if this is true, right, then that means that this component here must be 0. And in fact, it is 0. Because when n is equal to 1, you get 1 minus 1 times d. Because you're not adding a common difference for the first term, right? The first term is u1, so that's n equals to 1. And you don't need to add a common difference because that's only true for every subsequent term in that sequence, in that arithmetic sequence. And so that's why it happens to take the form of n minus 1 times d. Now, there's other ways you could write this that we'll see in a moment, but for the purposes of clarification, let's say we take this sequence 1, 2, 3, 4, 5, 6. Okay, so what would this look like? It would look something like this. So un, the general expression of this sequence, will equal to u1, which in this case is 1, plus n minus 1, which will stay the same as n minus 1, times the common difference, 1. And so now if we checked every single value of n, really this is a question of you plug in a value of n, and then you get the corresponding term in the sequence. So if I say n equals to 1, I'm going to get u1 equals to 1 plus 1 minus 1 times 1. Really, this equals to 0, so then u1 is equal to 1, and that's what I expect, right? Because my sequence of interest is something like 1, 2, 3, 4, etc, etc, etc. Now, what happens when n equals to 2? When n equals to 2, I get u2 equals to, well, the first term u1 will always be the same for the specific arithmetic sequence we're dealing with, so u2 equals to 1, plus n minus 1, in this case n is 2, minus 1 times 1 equals 2. This is 1 plus 1 equals to 2. And that's exactly what I expect, right? And so really the main point I want you to extract from this video, or from this part of the video, is that you can write, there are things called sequences that are essentially strings of numbers in sequence, right? 1, 2, 3, etc. And these are very important things that we need to know about in general for, let's say, science and technology, and it's just a fundamentally important mathematical concept. But because it's too cumbersome to write out every single term in that sequence, what we do instead is we find the general term given by un, which for the case of arithmetic sequences is that whole u1 plus n minus 1 times d business, and then we start working with this instead. So we don't have to write 1,000 different terms in our sequence. We can just write a few terms, then write what the corresponding equation for that sequence is, and then from here we can solve our problems. So for instance, if I asked you, well, what is the 273rd term in this sequence, right? Instead of writing out 273 terms, what you could actually say is, okay, well, I'm going to use the rule. So u1 we said is 1, because that's the first term in the sequence 1, 2, 3, 4, 5, etc. And then plus n in this case is 273, minus 1, because we're not counting, like when you have u1, you don't have to add a constant term, right? It's only for u2 and above, hence the minus 1, and then multiplied by 1, which is my common difference d. And so what number should I expect to be on the 273rd place in this sequence? Well, that number would be 1 plus 272, which again is 273, which is to be expected, right? Because u1 is equal to 1, u2 is equal to 2, u3 is equal to 3 in this specific arithmetic sequence. Math can be difficult, but it doesn't have to be. Let's clear things up together. You can use the link below to schedule a one-on-one session with me. Make sure to like, comment, and subscribe to get notified when I release new content. Thanks for watching, and I'll see you next time.